Good afternoon, everyone. My name is Nadia, and I'm a machine learning engineer at Wave. And I'm honored to be here today and to have the opportunity to introduce some of our amazing speakers. Before starting, I would like to remind you all that if you have a question, please post it in the chat. I will collect all the questions and ask them directly to our speaker on your behalf after the presentation. Our speaker for this session is Elle O'Brien. Elle O'Brien is a data scientist at Interactive Incorporated, the team behind database and control. She holds a PhD from the University of Washington and has presented about data science, AI, and statistical methods at the University College of London, Rev Data Scientist Summit, the American Statistics Association Symposium of Data Science and Statistics, and more. Previously, she conducted research in computational neuroscience and speech perception and worked as the chief scientist at MLOps, an AI comedy writing collective. Please join me in welcoming Elle O'Brien.
Hi, everyone. I'm really happy to be here. I've seen some really fantastic and exciting talks so far, so thanks for having me. Today, I'm going to be talking about something called adapting continuous integration and delivery for ML. All right, so first, a little bit about me. Some of this just got said. For most of the last decade, I've worked in academic research in various areas of neuroscience. And one constant in my work is that I've always done a lot of mathematical modeling, and I'm really in it for the big computers. I love getting to use big computers. And when I got my PhD last November from the University of Washington, I was interested in how scientists, whether in academia or industry, are going to use computers and how we're going to build tools that enable high quality science as our methods and data sets and problems are all getting more complex. So I joined Iterative.ai as a data scientist, and our flagship project is open source software called Data Version Control, or DVC for short. And this is our amazing owl logo. And DVC is a tool that adapts version control systems that software engineers are familiar with to machine learning projects. So as an organization, we're really at the intersection of data science and engineering. And I want to share one of the big ideas that's on our mind right now. So let's start with a figure from a case study that I love of teams all across Microsoft. The authors reported that teams, whether they worked on speech or search or ads, tended to follow a pretty similar workflow on software projects that involved machine learning. And of course, there's a whole bunch of folks with different skill sets working on this. We have data engineers who collect, clean, and label data. Data scientists are engineering features and then training and evaluating models. And software engineers are deploying and monitoring applications built around those models. And this is, for the record, an organization staffed entirely by baby animals, and that's completely normal. Anyway, all this is fine if the project goes linearly with everybody passing off their parts of the project like a relay race, but we know this doesn't happen. You know, we know that excellent ML models are going to rely on feedback, which means that software engineers and data scientists will frequently pass several modeling experiments back and forth. And of course, there's the problem of amazing experimental models never going into production. Data scientists need to be able to anticipate the system constraints of the software engineers that are going to be deploying their models. Otherwise, you get a bottleneck. And everybody on the team needs to be able to trace where the data came from. So there's a lot of back and forth, and it gets confusing pretty quickly. Now, machine learning is a new part of software engineering workflows, and software engineering teams across many domains are finding that they're trying to get into it. And it isn't always easy to incorporate into the structures and conventions that teams have. But software engineering isn't a new discipline, and we can learn a lot from the field's evolution. Specifically, DevOps has had success bringing together developers and operations specialists. So we're hopeful that in MLOps, we can bring together engineers and data scientists too. So can DevOps help? I think so. One of the big ideas from DevOps, which has really changed the way multidisciplinary teams run, is continuous integration and continuous delivery, which we're going to abbreviate CI/CD. And CI/CD is a practice that establishes collaboration rules between developers and operations specialists. So let's take a look at what that means. When you make a change in your source code, a build happens automatically, and then some tests get run on that build. And if the build passes the tests, then the modified source code becomes a candidate to be merged into the main branch of your project. And the idea is that every action, like a git, commit, and push, will trigger feedback, and every round of feedback produces a release candidate. So let's take a look at what's different when machine learning is part of the workflow. So now it's not enough to just monitor changes in your data, in your code. You also have to be looking out for changes in your data set, because we know that ML models are, there's complex dependencies on your data and the ways it's transformed. So if you change anything in the raw data or the ways you're transforming your data, that should trigger a round of feedback. Now, instead of building software in the traditional sense, we're training models, and training models can require specialized hardware, sometimes GPUs, and sometimes a lot of time. And now, instead of running tests that have clear pass-fail, we're often evaluating models, in a kind of a complex space. We're looking at numbers like accuracy, precision, many other metrics depending on the application. And whether or not these metrics have improved can actually be a bit subjective. Some will go up, others will go down. And deciding if this is a change that we can live with is a job sometimes for a data scientist. So I've kind of gone over a couple reasons why CI/CD is going to be different for ML, and I will say that it's not going to be trivial to implement these things. So for example, existing version control systems don't always track changes in data sets. If you have a pretty large data set, it might be outside of Git or something that you're not putting on your GitHub repository. So if your project is outside of version control, if your data set is outside version control, then that means that changing the data set won't trigger the build. Another is that training models isn't like building software. So if you are trying to train your model, it could be quite expensive or require specialized hardware. So some things that maybe you didn't need when you were, compiling a build. And evaluating metrics is more complicated, like I said. So what's needed? We think that we're going to need to build tools that extend CI/CD practices from software engineering to ML. And that's what we do at DVC. So DVC is one of our first attempts, and now I'm going to show you something new that we're working on. And so I want to start with a wish list. So these are some of the features that we might want if CI/CD is going to work for ML. We want to be able to version data like code. We want our CI system to be able to allocate whatever hardware is needed to train models. We want metrics about model performance to be reported in a human readable format so data scientists and other team members can efficiently review them. So here's how we're approaching it so far. And the work that I'm going to show you is a collaboration with Dmitry Petrov, he's DVC creator, David Ortega, he's a developer, and myself as a data scientist. Okay, so here's kind of the tactic we're taking. Our team is really into the Git ecosystem. We like Git tools because they're so well established in the software development community, and we think they can be adapted to work better for data science projects. Two services in particular have really caught our attention, and that's GitHub Actions and GitLab CI. These are systems designed for Git-centric continuous integration. And there's a tremendous overlap in what you can do with GitHub Actions and GitLab CI. So for simplicity, I'm going to focus on GitHub Actions in this talk, but please keep in mind that everything I say and show you is also possible in GitLab. So if we revisit this figure, where do GitHub Actions or GitLab CI fit in? Specifically in this stage, you can automate model training and testing with GitHub Actions or GitLab CI. So GitHub Actions is a service that is going to run a workflow defined by you every time a triggering event happens, like a change is pushed to your project repository. And by default, the workflow is run on runner machines that are provided by GitHub. but you can use your own machines too, and we'll revisit that in a bit. So I'm going to take us through the priorities we laid out one by one and show you how we've handled them. So first, let's talk about providing feedback in the form of metric reports. Okay, so let's say we have a project on GitHub, and we're using GitHub Actions to automate training and evaluating a model. So we're going to create this YAML file and a special file path in .github/workflows. And this is the secret sauce for any GitHub action, where we're going to lay out the workflow that will be carried out every time we push. So a couple things to note: we're in the special location in our file path. We're setting a trigger. So we're defining, okay, whenever there's a push, that's when this workflow is going to be run. We're picking out an operating system and a Docker container for the runner. And this runner is going to be handled entirely by GitHub. It's really nice. There's a free tier. So you just pick out the runner that you want, what container you want on it, what operating system, and they'll take care of it. Here, we're going to run in Python, our training script. Oh, and by the way, we put Python in our custom container, as well as a couple of other custom functions. And those come up here, is that we built some helper functions that are basically going to take some data that's output by our Python training script. So things like model metrics that are in a text file, as well as a PNG image of a confusion matrix that have been generated by our Python job. And we're going to create a markdown report featuring those. So what happens with this report? Well, it gets delivered to GitHub. What do I mean by that? So when you make a pull request, you'll see the report show up as a comment. So now things like the model accuracy and the confusion matrix are visible on your PR. And so now that it's visible to your team, you can hopefully make a more informed decision about what you're merging. So let's look a little closer at what exactly is run in my workflow. So we've got a training script, Python train.py, and then we're doing some bash scripting with our helper functions to add the reported model accuracy and confusion matrix to the report and deliver it to your pull request. So I'll show you another example. So this is one with DVC. So DVC, it works around Git. And so you can, if DVC tracks metrics for you, so you can pick a number like an accuracy that you're going to track throughout your project, and kind of like how you can do a Git diff comparing, what's on one commit with another commit, you can do that in DVC. You can do a metrics diff, and DVC will print out a table for you. So here I've got a metrics diff. So on this pull request, what happens is we're getting a table comparing some metrics, accuracy, precision, and recall to the model that's on the pull request with the head of master. And so we've also got a table here, and a plot, and this is a plot created by DVC plots, which is a new feature for Vega Lite plots. Oh, and I'm seeing somebody in the questions asking, what's CML publish? It's a secret code name for our project. So they're just helper functions we've written. They're not released yet, but CML is part of the project name. That's why they have that suffix. Anyway, we've got this plot here, and it's a Vega Lite plot, but it really doesn't matter. You can put any kind of plot you want in it. And another example is that we wrote a wrapper for TensorBoard so that when you start model training on your GitHub runner, our helper function will deliver a comment that contains a link to the tensorboard.dev page, so you can watch your model train in real time on a runner. Basically, we have been making reports with the idea of maximum flexibility. You can put anything that can go in a GitHub Markdown document in your report. So you could make your plot using whatever visualization library you prefer. It could be Seaborn or ggplot or Vega or whatever. We're trying to take the tack that data scientists have tools that they love already, so let's not force them into anything. Just use what you like and put it in the table. Now it's visible to everybody on GitHub. Okay, priority 2, we wanted to version data like code. So this is what DVC does. So the flagship project at Iterative is DVC, and what it does is extend Git versioning to data sets and models. And to be clear, it's not an alternative to Git or a replacement. DVC works with Git. So if you had a data set or a trained model file that's prohibitively large for Git versioning or hosting on GitHub, you would track it with DVC. And the syntax is similar to Git. You'd add and push it. And the syntax is similar by design. Like I said, DVC is extending Git. So here's what happens when you push. you pick whatever kind of cloud storage you like to be a data remote. So you take your S3 bucket, your GCP bucket, Azure Blob, whatever you like. And so DVC, when you add that data file and push, will coordinate sending a copy of your data to that remote location. And on your local machine, DVC creates a lightweight metadata file that can be tracked with Git. So this is a sample file, and it contains a hash that indexes the version of the data set as well as its location in cloud storage. So to use this in GitHub Actions, you have to pass some credentials to the workflow, which you can store as secrets. Or in GitLab, these would be variables. So here's part of the workflow file. This is just the YAML that's in GitHub Actions, GitHub/workflows. And so this is just saying, get these environmental variables in my container, in my runner, based on these secrets that we've provided. And when you then are in the workflow, you can do commands like pull and push. So what happens here, when I am pulling the data, DVC is going to find, okay, data, it's going to look in the GitHub repository for a data.dvc meta file, and it's going to take the hash that's inside that and use that to find the address of the actual data file contents in our cloud storage. And then it will take that CSV file and bring it to the runner. And likewise, if I produce something like a model.pickle file in my workflow, then I can take that and have DVC track it and put it into cloud storage. So you can keep, use, and track files that never get stored in your GitHub repository, so you're not beholden to file size limits. Okay, so some consequences for CI. One, changes in data sets can trigger GitHub Actions even if the data set isn't Git tracked. If you change your data set, DVC will detect the change and it will update a file that is tracked by Git, so that can trigger one of your CI loops. Next, GitHub Actions can push and pull big artifacts to cloud storage. There's definitely other ways to do that, but a lot of data scientists that we talk to and ML engineers really like the kind of abstraction that DVC in particular gives you. They think it's a pretty smooth experience to push and pull things to cloud storage this way. And also, data and model versions are going to be linked to every model training run. So you won't lose track of, okay, what data set did I use on this training run and what model file did I create? They are all linked through Git versioning. And so while I can't make the claim that this is entirely serverless because of GitHub Actions is, you've still got things like a Docker container. But it's a pretty good step closer to serverless. So you've got object storage in a serverless environment, like, whatever your bucket is, plus now a GitHub runner that you do not have to provision yourself. Okay, so priority 3 is let's let CI system allocate cloud resources to train models. And this is my favorite feature. So you can use cloud computing resources in a CI system. And with Docker machine, you can create a GitHub action that will launch instances whenever a workflow is triggered. So what that means basically is that GitHub Actions is going to start a job that's on a GitHub runner, but then using Docker machine, it's going to provision and deploy your cloud resources, whatever you told it. It could be your EC2 instances, for example. And what that means is that you can just push to your repository to initiate training in the cloud. I think that is awesome. It feels great. So you can just make the change to your code from anywhere, push it to your repository, and that will boot up your EC2 instances. And another neat thing about this then is that your entire training setup is codified. So here's an example. We've created GitHub Actions workflow that first provisions a new EC2 instance with the GPU using Docker machine. And then we set this machine as our workflow runner and run the training script. So here's an example on style transfer. Style transfer is a lot of fun. It's pretty painstaking with the CPU. And so here's an example where I've done style transfer. On the master branch, I have a current parameterization of the model, and then I made a pull request where I changed some parameters of the model, committed and pushed my changes. And then in the pull request, I'm getting a report of what the style transfer looks like now compared to on master. Some training metrics are printed out, and I also printed out the info of the GPU that this ran on. And another really cool thing is that because the runner automatically shuts down after a certain idle period, you don't have to remember to turn your cloud resources off. You also don't have to boot up your cloud resources and interactively modify your code on them before training. And you can modify your code from anywhere, like I said. So as soon as the change is pushed, the CI system will take over and start your cloud compute instance. Okay, so just to recap here, we laid out 3 things that we wanted. We wanted to version data like code, and we're using DVC to do this. We wanted our CI system to allocate cloud resources to train models, and we showed how pairing up Docker machine with GitHub Actions can let you do this. And we wanted to provide feedback in the form of metric reports, and we have written some custom helper functions to help get metrics or other, images, visualizations, interesting data from your model that would help somebody make an informed decision about that model into the Git flow and the GitHub PR. So to be clear, there are lots of solutions out here. This is definitely not the only way to go about this. And plenty of companies have built their own internal custom platforms for managing ML experiments. Lots of teams do it manually, figure out their own way. And our goal is not to create a whole new platform that organizations have to learn how to use. We're interested in an ecosystem of tools that are going to augment existing workflows. And the priority here is making data science and DevOps more closely tied to the CI/CD process. And, we really are excited about CI and CD because we think they make a lot of sense for a lot of machine learning projects, especially full stack projects. CI/CD gives you a way to bring together training data, source code, and modeling experiments all in one place. And that gives everyone on the team access to all versions of the project, including history and ongoing experiments, and provides a standardized format for storing and sharing any kind of files related to the project. And this is a cultural and technological shift that could be as important for full stack ML teams as DevOps has been for software. So thank you for listening. So some of the helper functions and these approaches that I showed you, we're gearing up to release probably in about 2 to 3 weeks, beginning of July. We're really excited about it. So if you follow us on social, that's our organization Twitter, my LinkedIn, and we will keep you updated when these things are published. So really excited about it, and we're open source. So we hope that you'll join us in building the next generation of MLOps tools. Thanks.
Thank you so much, Elle. It was amazing. So I really enjoyed the presentation, and I also see that the people that were attending really enjoyed, because I have a long list of questions for you.
Cool.
Okay, so I'll start with some general question about the product. So I think you already answered the first one, but just to maybe make it more clear, are all the features you are presenting here published already and available?
Yeah, so we've kind of done a very limited run where we've shown it to some people that are, outside our organization to give us a little bit of feedback, but we're going to do a big release, like I said, in the beginning of July.
Amazing. So the next one is, does it also work with images, or it's only for structured data?
Oh, you can use any kind of file. You can actually put an audio file in too. So what we have is a little hosting service that will take your image, even if it's ephemeral and never committed to the repository. And it will, host your data file, any type of file, and then it will embed a link to that inside the report. So, if you had an image file, obviously it wouldn't, or, images, as long as they're a format that is supported on GitHub Markdown, then it will appear in the report. And if it's not a type that is supported by GitHub Markdown, like you wouldn't see it in a GitHub README file, for example, then we'll just give you a link to it and you would just follow the link.
Okay, cool. Does DVC let you visualize or inspect the difference between changes in your data?
So it depends what you mean. If you are saying like, I have transformed this column of data to the next. Not really. It doesn't really take advantage right now of the structures that are there. It will mainly tell you that it has changed, but it doesn't have necessarily like a viewer to understand what was the algebraic transformation that changed. If you are using like, yeah, no, I think that it's more for something changed. And not a big description of what changed. But if somebody logged a commit message, that said, this is what I changed in the data, then it will make it clear that way.
Yeah, you can for sure overcome this feature. Okay, so how would this work when the data is stored in a data warehouse?
Yeah, so so DVC works for data that's on the scale of something that, you could conceivably have on your local machine and then transfer into S3, so if all your data is huge and it's already in a warehouse and there's no way of kind of bringing that to your local workspace to start DVC tracking it, then it's probably beyond the scope of DVC. And then there's probably other tools that are for that. So we're kind of for data that's in like, the 100 megabytes to maybe 100 gigabytes kind of range. So you have to do some transfer.
Yeah, you probably have to extract those data you're using and track the extracted part. That make more sense probably. So do you have any sample in GitHub Actions Marketplace?
Not yet. So that's another thing that we're aiming to do. We're hoping to put this as an action in the marketplace too. Yeah, so look for that beginning of July.
Thanks. Okay, the next one is longer, but I'm gonna read slowly, so hopefully I will do a good job. I can see this working great with, say, Python training scripts, but usually you would start with the Jupyter notebooks. There has been a lot of convo recently about how notebooks make it messy to move to more productionalized Python code. Are there plans to integrate DVC with Jupyter notebook changes to track model training progress?
Yeah, okay, so I think this is a really interesting question, right? Because if Jupyter notebooks are contentious, and I'm kind of the mind that even though I don't personally use them, I think they have a place in a lot of development workflows, especially if you've got a pretty diverse team, and that's the way that some of your team members are going to be integrating with data or, looking at your progress. So I think they've got a value. And so we have people in the community that have been working on this. I do know that I'm pretty sure there's at least one package out there that will let you Git version Jupyter notebooks in a way that, is at least a little bit intuitive or good, but I haven't personally tried it. But something interesting that I saw, there's a blog that we shared around on DVC social media recently. One of our kind of contributors and friends, he used a beta called GitHub Code Spaces that actually let him use notebooks in a really interesting way with Git and GitHub. And I thought it was beautiful. And I can't remember the details, but I would refer that person to check out this site and check out how they had orchestrated a system using notebooks that would be compatible with CI/CD.
Yeah, I think also Jupyter Notebook Lab allow you to automatically track your changes in GitHub. So maybe it's an option. So now we have like a couple of questions that are more related to product comparison. So the first is they ask you to compare DVC and Databricks Delta Lake. So what's the difference? Are they the same product or not?
So I haven't actually used Databricks Data Lake, so I don't want to say too much from, maybe a not very enlightened part. I would say that DVC, is not a data lake in particular. It doesn't offer a data lake type service. DVC is for, pick whatever storage you want and keep your data there. So I'm not familiar enough with that product to make a smart comparison. Sorry.
Okay, so there should be, let's see. Okay, still a comparison, but this time with MLflow. So DVC looks similar to MLflow. Are these the reason to pick one over the other one?
Yeah, so, MLflow, I think, takes a slightly different philosophy. If MLflow is a platform versus DVC is trying to create individual tools that can be modularly put together in an ecosystem for people to pick and choose. So I think there's a bit of a difference in philosophy about how your team will use it. So I think MLflow is kind of trying to be end-to-end is my sense. Whereas I think DVC is really ideal for a team where, some people might not be ML engineers by trade. They might be software engineers that have, a lot of conventions, entrenched ways of doing it. And we're trying to build into that ecosystem of tools.
Yeah, if I can add to this answer, I personally use MLflow, but I'm using it for tracking experiment. So I like to add some metadata to each of the experiment. So in this case, instead, it's really like building up the CI/CD pipeline. So.
Yeah, we actually have users that use both DVC and MLflow. They are compatible products. DVC, some people have started using on their CI systems, but then, MLflow is great when they want to go in and explore a really big space of hyperparameters, for example. So, we have people using both.
Perfect, thanks. So we have a follow-up question on the type of data you can track. So regarding data versioning for image and audio dataset, does DVC track changes in binaries, or does it only track changes in a file name path?
Oh, it tracks changes in binaries. Yeah.
Awesome. So let's give a couple of minutes to maybe any other question to come up.
Oh yeah, some great resources in the chat. Thanks.
Yeah, I see all the stuff you mentioned. Someone took care of, found the link and posted in the chat. That's amazing. Right. Thank you so much. Okay, so it seems that we don't have any other questions. So thank you so much, Elle. It was really nice. Open up the last one. Can I filter, adjust the sensitivity of change detection in DVC? For example, don't trigger changes on a minor edit.
So DVC basically, DVC doesn't ever auto commit or anything. So you use DVC manually the same way as you use Git. So you decide when you're going to snapshot it. But, you can, for example, in the CI/CD loop, if you don't want to run, every time, we are building in a flag onto some of our helper functions and such, for example, so that you can commit to a project and not trigger CI skip. It's called a CI skip flag is what we're using. But yeah, DVC doesn't ever automatically snapshot for you. You pick every time.
Perfect. Thank you so much. So it seems now we are done with the question. So thank you so much, Elle. It was really a pleasure for me to moderate the session, to hear your presentation. And I'm pretty sure tomorrow I'm going to start to play with DVC because it really looks like very interesting. So thank you again. Thank you for joining MLOps.
Thank you. Bye.
Bye.